everyone, welcome to the session. And let me introduce myself. My name is Olena. I actually come here from a cold Germany. I really enjoy the weather here, and I must say that the fruits and veggies and everything you have here is so amazing. So really happy to be here at this event, and I'm going today to talk about agentic systems. And we are going to build agentic systems with Apache Kafka and Apache Flink. Could you put on the slides? I mean, I can also talk about without slides, but with slides it's usually a bit better. So we are going to look through a lot of things, and I hope that I will bring you some small recipes which you can use later, or some ideas, and also maybe I will inspire you doing something. So we are going to look what are agentic systems, what they are not, what kind of building blocks we can use, what kind of architectures we actually rely on when building agentic systems. We are going to look into RAG patterns, the Retrieval-Augmented Generation, prompt engineering, different types of architecture flows, the big role of event-driven system or event-driven architecture when we are building agentic systems, and especially Apache Kafka and Apache Flink. Then we are going to build something together. So I'm going to show you some demo which you can also use for your inspiration. So before actually we start, I wanted to ask you, how many of you, actually let's start with a basic question. How many of you actually use Apache Kafka in production? Yeah, nice. It's like majority of the room. How many of you actually use, I saw someone raising two hands, so two productions, I guess. How many of you are using Apache Flink, or maybe not in production, just using, it will be, okay, we have still a good number of rooms of people in the room. And how many of you actually are working with some agentic workflows or building agents? I mean, ChatGPT, I guess everyone is using, but okay, we do have some hands raised, so we can also talk, so you can share your experience with me later. Anyway, so let's start with definition and types and architectures which we use. And here, of course, I can give you my opinion on what is AI agent, but I wanted actually to use some reputable sources. So I went and looked at different definitions, and you can imagine actually in nowadays, because the field is evolving so fast, it's very kind of like what is agent really depends whom you ask. So I here selected definition which IBM gives us. So an AI agent refers to a system or a program that is capable of autonomously performing tasks on behalf of a user or another system by designing its workflow and utilizing available tools. So here the important, I think, parts of an agent is that we are using some kind of tools. We have some kind of workflow which can be very complex or not, and then our agent can autonomously perform those. So if we are looking at agentic system, it can be seen as a autonomous, highly skilled specialist, which can work with the workflow, so split tasks into subtasks, coordinate some actions, also collect all the necessary information which we need to perform the task from whatever data sources you have, whether it is a semantic search or maybe some other databases or some other sources for past conversations, whatever you have. Then oh, so bright. Then we have large language models, which help us to reason and use a natural language processing to work with all that source of information. And finally, the large language models, or we on behalf of them, can reference those tools which we have to send emails, to schedule meetings, to do whatever actions you want to have. Actually, maybe don't use an agent to send emails because that would be, can turn as a disaster. But anyway, so this is what agent is. And then when I was looking at definition which Anthropic gives us, there I liked the way how they say that an agentic system can be either based on workflows or agents. And this is where the complexity is quite different. And I wanted to share with you because I think it's also so we kind of understand where the limits are. So for me, still the agent is a program which needs to use some kind of tools and have some kind of this autonomicity, but still. So workflows, based on what Anthropic says, is where large language models are tools, and tools are orchestrated through predefined code path. So maybe for your use case, you don't need something overly complicated like, I don't know, Anthropic's operator, but you kind of already can see what tasks you need to split your goal into, and then you can perform those one by one. Whereas agent is where the LLM will dynamically direct their own process, decide on the task, for example, like solve a programming issue like they're doing to evaluate LLMs on solving the GitHub issues. So this is where this is kind of a very sophisticated agent. What kind of agentic system you need? I would say that you don't really have to go for the most complex solution from the beginning. Actually, the opposite. You want to start first to understanding what problems you are solving, and then you are trying to actually go with a simple solutions and increase the complexity, increase till you actually find what you need, and not really go to, I mean, this is not the competition who builds the most complex system after all. And also maintaining those systems is difficult. So now talking about building blocks, and this is actually, again, this is from Anthropic. I tried also to reference so that I'm not stealing their graphs from their papers. But the building block, the most important building block is the augmented large language model, which is enhanced with three different things. The way to retrieve the information, the way to access tools, and the way to access memory. So this is what we need for our systems. And when we are building our systems for agentic workflows or agentic systems, I didn't want to skip the part of the frameworks which we might want to use to build in those. And this list is very, very short. I mean, like, this is actually like selected. If you, like, there are hundreds and hundreds, maybe thousands of different frameworks and libraries which exist right now for agentic systems. And it's amazing because it shows the interest of all developers to the agents and to AI. However, sometimes, and actually I would say, I would say that most of the time, if you especially start in using to work with AI and with agents, it might be better to omit usage of frameworks at all. So the large language models, they provide APIs, and you access APIs directly, and you don't really need LangChain or LangGraph. And I have a high respect to those libraries, but also think that actually, if you look at LangChain and LangGraph, they exist for a while, especially LangChain, and it's kind of a bloated library. So you will spend more time fighting with the library instead of kind of actually building your stuff. So maybe it's, I don't know. But I would actually maybe point to two of those frameworks. Or actually, I put MCP here as a framework. It's actually a protocol. But I wanted to point out the MCP, so the Model Context Protocol. So this is a thing which I think over the last 3 months, we see the usage, and over the last weeks, so many people are talking about MCP. It's more or less, so here I actually left the link also for the MCP server, which my colleagues at Confluent built. So imagine you have your Kafka cluster, and then you have our large language model. So here, for example, Anthropic, and you're talking and asking like, could you tell me what is the topic, like the information about this and that topic? And the large language model, using the API which you specify through this protocol, will access your cluster, will retrieve that information and share with you. So it's a nice way for certain scenarios where you can use the API of whatever product you have. And then through this protocol, the large language model will know how to access those APIs. Super nice. So this is one. The second one which I want you to pay attention to is the Agent SDK that was released. This is from OpenAI, released last week. Offers a very nice, so far only in Python, set of tools to work with agents. But the rest of frameworks, I mean, it's all up to you, but I would start simple. I would not even bother learning the framework, I would just go directly to the APIs. So now let's talk about workflows. And workflows is like a building blocks for our agents. And we have, for example, prompt chaining. This is where you decompose a task into a sequence of steps. And then each step relies on the result of the previous step. And the task we use is usually where the whole goal can be easily and cleanly decomposed into a set of fixed subtasks. So this is pretty straightforward, no much of complexity. You have some gates to see if something didn't work, you just exit. Then we have routing or routing, how it is to pronounce anyway. So this is to classify an input and direct to a specified follow-up task. And this is where maybe distinct categories of tasks can be better handled separately. There's also kind of, so where, for example, here, LLM call router, we give only one task, and then each part responsible for only single small objective, and then LLM usually gives a better response for that. Yeah, so, and then we collect the result. So this is actually used sometimes where you want to route, like you have easier tasks, you route it to the smaller models, or you have more complex tasks and you route it to more complex, to more sophisticated models. So you also save kind of on the cost of the models which you use. Yes, then we can run stuff in parallel, either for speed or for higher confidence of the results which we get, or with, for complex tasks with multiple aspects. So again, we can separate this into separate different calls and then aggregate the results. That might be better than doing it within a single model call, because LLMs also, like, you know, it likes to talk and think, and if you give a smaller task, it will be a bit better. Then we have orchestrator workflows, where the central LLM will dynamically break down tasks, delegate them to worker LLMs, and then we will synthesize the results. It is also like where you cannot really predict what kind of subtask you will need, so you create an orchestrator for that. And finally, how like the one of the flows, which is by Anthropic, how they see the agent. So agent, once the task is clear, agent will plan and operate the task independently, potentially getting to the human back for some particular tasks. But otherwise, it will like interact in the environment. So this is kind of the next level. So you have probably heard about operator by Anthropic, or computer use, I think it's by OpenAI. So those are very sophisticated agents. Maybe you don't need to build that one, even though it would be cool to have maybe more of those solutions available. So, and here I wanted like all those different architectures where the agent logic is divided into steps, and then each step technically trigger an event, and then or like each step emits the events, triggers further actions, and we can use those events to do the looping logic, to do the branching logic. The agent can decide to stop if, for example, feedback is positive, and so on. So we are here actually talking about event-driven architecture. So all those different modules, we sometimes want to go like to the embedding model to get some embeddings. We want to talk to LLM. We want to send the calls for external APIs and so on. This is all event-driven architecture. And when I'm actually reading, it's not like I'm even stretching this idea, because I actually, when I'm reading, a lot of people on the internet discuss how they're building those agentic systems, and actually that in the end they end up using event-driven architecture, or at least like a lot of references to those. And I think it's for a big reason that those are kind of fit very well, and especially like we use event-driven architecture to have loose coupling, to be able to scale, to be resilient, flexible, and so on. And this is what we want in those complex systems with a lot of different dependencies. So so this brings me to this slide, which I put a lot of effort to create. So we have Kafka, Flink, and I think they all really work nicely with agentic systems. So let's look at the use case now. And the use case, I just wanted to have some kind of example. Nothing too complex, taking into account how much time we have. But let's look how we will design an agentic system, create an agentic system, which is designed specifically for pet owners. So it's like one-stop solution for getting some information, scheduling some visits, booking grooming sessions, and so on. So we have different tasks, and we want to have an agent which helps us to solve those tasks. And the architecture which, like the flow which I have in mind, is that so we get some requests from a customer. Something happens to their pets, and they're like, okay, so I will write, or like it can come as an email, it can come through the chatbot, it can come however the information comes, but we get that information from the customer. We know, for example, ID of the customer. But first thing which we need to know is to figure out who is our customer, what kind of actually pets they have, or like what is the animal, what is the age, so that we can actually later give a good recommendation, or later when we are scheduling, for example, the veterinary visit, we know where they live, or maybe who is their regular doctor, and so on. So we need to make a couple of calls to some databases. This is even before we actually try to call large language model, but we need to get that information. Then we need to maybe we have some kind of documentation, some kind of resources which we use, which is very specific for our product, and we want also to reference those. So we retrieve some information which is related to customer request. Then, of course, we make some LLM, maybe we even take triage the request, because we know that there can be totally different questions coming, or like issues coming from the customers. So we triage that, and we decide what exactly is the action we will do, and then we will put it all together. So this is just an example of the system. I tried also not to overcomplicate it, because it wouldn't fit on the slide, but kind of to give you an idea. So we have kind of turns in all this system. So let's step by step kind of build this pipeline. So first you get information somehow. So I actually just put it into the Apache Kafka topic, and I put a request from the customer that my cat does excessive grooming, so like kind of I have an issue with my animal, and I would like to have some advice. Do I need actually to schedule a veterinary visit? So here I'm relying both on Apache Kafka and on Apache Flink. And technically here I just actually, the first step, I just wanted to show you that I have a topic in the cluster. And in the topic for the customer ID 3, I have this request, so I got the data. So now we will build our pipeline based on that entry. So we know here the customer ID, which will be for us important, and also we have the conversation ID in case we want to iterate on that, and we have a timestamp. So next, we want to collect information about that particular customer, whatever details we can get, because later it will help us to understand how big is the issue related to like, do we really need to schedule that vet visit, or actually this is just something very easy to solve by giving a recommendation. So here, to collect information, when we are working with large language models or agentic systems, we usually split the data sources, or like, let's say, memory augmented planning. And I'm here using some words from the paper which I was reading on the topic, into two categories: embodied memory or retrieval-augmented generation. So embodied memory is what your model knows about. And we know models are very smart. So they are trained on some data. We can fine-tune them on some additional data if we want to. However, usually, this is a tiny fractions of all the use cases, because fine-tuning a model or training your separate model is, let's say, it's an expensive task. And also, you wouldn't really fine-tune a model on all kind of information. So you generally want the model to know the domain, but then you will add additional context, usually using what we call retrieval-augmented generation. I will refer to it as RAG. So this is retrieval-augmented generation is where we want to have some additional context. And this can be like real-time details. So what is like traffic right now in Bengaluru? We know it's probably very, very chaotic, but it's kind of like we want to know that information. Or like, what is the weather conditions outside? So what is the latest trends in the stocks? So we want to retrieve that information. It's information for this moment. So it's not like that we can train the model based on that. So that's one of the examples. Another example is specific information about our customers, their names, their tax class, whatever we have. And this, again, this is not information which we want to train the model on. And also it's very dynamic information because we have more customers joining our product. So we cannot really like have that, we need to really like to get that information from some external source. Or it can be like relevant information which is outside of the large language model core knowledge, like documentation of your product. So this is actually why it's better to include it as a RAG rather than part of the knowledge of the model, because you can notice if you're using like ChatGPT or Anthropic to help you code and build some stuff, sometimes it will reference some older APIs because it's what it was built on, versus you actually want to get the fresher way of do things. So this is also like quite nicely goes with RAG concept. And finally, some recent user-specific events, like whatever user is like, if you use Amazon, and I don't know how Amazon is using it, but so if they have some users who are interested in some products, we want to know that so that we can also use it maybe when we are replying to that customer. So there are different types of data which you can have using with RAG. So the fixed values, like those like name of the customer, like strings, integers, and so on. Tabular forms also I saw. Knowledge graphs, this is something I see more and more usage of that. So when you actually build kind of a graph based on those documents. We can have more complex use cases of which data needs to be retrieved based on, for example, recency scores. This also kind of I see being used, even though it's a bit more complicated. Then vectors and indexes. And finally, I included into this list something from the last week. We have this web search. This is a new feature from OpenAI, and this is where you actually just provide an access for OpenAI to go on the internet and check, for example, weather or whatever conditions. And this is actually quite interesting because we could do actually all of that even before, but now they just give us a possibility to do it without extra call so that we don't have to do it manually. But out of this list, I would like to talk about two of those. Fixed values, we are going to retrieve the customer information, and then using vectors and indexes. This is for our kind of the product documentation or kind of additional resources. So the RAG works like this. So we are getting the external data, then we technically just include it into the prompt. There is no magic to do it. It's kind of like, it looks very sophisticated when you say retrieval-augmented generation. It's like, oh my God, so complex. So actually, in reality, you make a call to external source, and when you are creating your prompt to large language model, you're like, okay, so I have this task, and here is additional context. So that prompt you send to large language model, and this is RAG. For us, I tried to use, or I used Pinecone as a vector store, MongoDB as the store with information on customers, and OpenAI as a model. And let's look at Pinecone. So this is a vector search. And with vector search, there are we can split it into two steps. So you have some document, let's say you have your documentation for your product, and you want to use a semantic search. And vector search, semantic search, this is kind of similarity search, all things kind of same concept. So we take your documentation, we split it maybe into blocks, and then we transform that information using embedding model, which transforms the text or images or whatever into numbers, and we store those vectors in the vector store. So this is first step. We are ready. So we are ready to search among those vectors for something similar. So then we take requests. So for example, we have a request from the customer, and the customer mentions something related to the health of their pets and some details. We do the same. We transform that into numbers. So we get another vector. And then we take that single vector and we compare it to everything we stored in our vector store. And we find the closest neighbors. So there is more information to this, but this is not a new technology. The vector search is actually quite an old stuff. It got popular because all AI technology got popular, but vector search is something which we are using already for a while, so there is a ton of good information you can find. So here, for example, I had Pinecone database, and I was using OpenAI embedding model to transform the records. By the way, whenever you're using semantic search, make sure that you're using the same model. So you want always to compare apples to apples. You transform all your documentation using a model. You use the same model when you are searching. Otherwise, you are going to compare apples to potatoes, and it doesn't really go well. So I had a Pinecone database with some vectors in it, so just that we can compare. Then this is definition of the model. This is done together with APIs which we provide at Confluent. So here I create a model, I give it a name, and then I specify exactly some details. It's embedding. I specify the connection information, where to take it. Also specify the version of the model, like here is embedding 3 small, so this is the exact model which OpenAI use, and the rest. And I also need to specify the input and output information together with the type of data we expect. Because we are working here with Flink. With Flink, we are managing the data, we are transforming, modifying, and we really want to know the types of data so that we can do it very reliably. So here I get a string as a customer request information, and then the return is embedding property, which is array of floats. So we have that. Now we can take that phrase or that kind of request from the customer. Using ML predict, we are retrieving the embedding for that. So the next step is to get into the table which I called customer message and embedding. We have all the information we had before plus an embedding which we got from OpenAI. So this is more or less like problem embedding. So we transformed, we have that. Next one is to access the vector store, so Pinecone. Here I'm using the same principle to create a kind of a table which I will be able to access through Flink. And with that, I'm actually having the next step, which I called vector store results, so a table where we populate all the data we had before, plus there will be a response from the Pinecone, which will return us the most similar results or from our documentation related to the information provided by the customer. The thing is, actually here, because Pinecone will return us a lot of different useful things, but not all of those things I want to have there. So this is kind of how the response will look like, and it's kind of like, you see, like it starts with a text, but then it actually includes also the vectors, it includes some other information, and I'm like, not exactly, I don't want to send that later to large language model, it's embarrassingly long. So what we do here, I want to process the information, and those of you who actually are good with SQL code, you probably can actually use that SQL magic to clean that up. I'm better with all other languages, so I used here a user-defined function. And this is also what we can do with Apache Flink. When we are using Apache Flink SQL or table API, we can inject some code. This one is in Java. You can also do that in Python. And here we define the name of the function, and then we are saying, okay, this is your input data. So, and then this is just it looks somehow complex, but it's just like I got a lot of stuff from Pinecone, and I want to clean it. So I say, okay, this is your input data, and this is how we are going to transform, we are going to extract text. And then some magic stuff which I actually did with the help of ChatGPT. So we are getting that information, and then finally we can run that and move to the next step. So here I move to the step customer message and resources. So now I would have everything which we collected before plus information about from the Pinecone database so that I can use it later to call the LLM. So this is the first step. This is similarity search, so this is semantic search, or however you want to call it, where we use the vectors to find similar things. Another recipe I wanted to share is that you actually might not use the vector search, but you will use some other data store, something like MongoDB or whatever. It can be like any OLTP or even other types of databases. And with MongoDB, I wanted to show you a different approach how you can do it. Because we can technically, so this is the data which I have in the MongoDB, and there are like customer information. So I just put some examples, like something related to the pets, like what is the age of the pet. So we can kind of use that information with LLM. And we can we can sync all the data from MongoDB to Kafka topic. So we are using Kafka connector because this is actually MongoDB has a good Kafka connector which we can use. So, and then one thing I wanted to pay attention to is that we need a schema. So, because again, here, the better types, if you're using types everywhere, you will have more predictable results. You want to make sure that you are doing some steps which like will be kind of correctly done, not really like wondering if it's an integer or is it a string or something. You want really to specify the schema. So what I did, I created a topic in MongoDB, created a connector using our schema, and then populated MongoDB with data. And then in the end, if I go and look into my topic, I would see that I got the information from the MongoDB. There, it's all there. I have the customers. So I can use the inner join to get the data and join it with what I previously had about the customer. So now, not only we have all the related documentation information, we also have customer details. So now we are ready with all of this to make a call to large language model. And here, before like going into triaging logic, here I wanted like just to show how we finish this retrieval-augmented generation scenario. So we had semantic search or whatever other search, and now we want to make a call to large language model. So what do we do? So we need a model, and of course in the model you have these two types of prompts which you define. So in the system prompt, I told that you are a helpful agent that has deep knowledge on pet care. So you are having a question, please give the answer based on the information. So this is just a general information about the model. But in the, and actually, yeah, so the types again, but in the request to the model, we provide all those information about what kind of allergies our pet has, or like whatever additional data, relevant documentation, we just put it as the prompt to the model. This is retrieval-augmented generation, where we add additional context to our large language model. And then if we run that, we get the response from the model, and model now can use that data in addition to all other knowledge you have your model trained on, or here's OpenAI model. So yeah, and here the model knows that it's the cat, and there are some details. So this is the first kind of flow, and now the thing is I'm running all those Flink jobs. So whenever actually a new request comes to the system, it will go through all the Flink jobs and will end up with the information from the large language model in the final table which I designed for that. And then that table I can use for whatever next steps. But this is a RAG example. But I wanted actually to show you kind of what do you do with the tools? How do you triage actually? If you want to have a bit more complex scenario, so you have in your workflow, you have a lot of different steps, and you have to use orchestrator, or you have to have some kind of a points where you are making a decision what to do next. And for example, like the triaging logic can look like this. So we have again create a model, but this model gets kind of a bit more complex request. We tell that model that it's designed to triage requests, and it needs to actually give a category, either user requests information, or schedules event, or books grooming, or we want to raise an issue. So all different types of those requests, and we give some information how to decide which is one. So, and retrieve only one action. Here we can actually play even more, like to specify the type of the response and so on. I knew that I need just one action, so I asked to retrieve just one phrase without additional words. And then when we make the request, because that was the definition of the model, and now this is a request which we get. Here we provide also information about the animal, or whatever like we have about the customer, additional information. And we remind that the task is to return one of the following actions. So sometimes you have to remind the model several times that it should do it, so that it doesn't really, models, they have a lot of their own opinions. But then if I will run this, I will get information, and here I just used a lot of values which I had. I would get like the result of the triage step. And now we can move forward and use the triage result to split our rows into particular tables. For example, we have triaging for the recommendations, and then we have a table specifically for that data, and we can process those requests from the customers separately, just making that step to the large language model to ask for recommendations. Or we might want to use some tools to schedule an appointment or do something else. With tools, you have a variety of choices how to work with them, and there are like some pros and cons, because you always want also to make sure, if, for example, you're using an external API, how do you make sure that if the request fails, how do you retry? So those, like a lot of complexity. So here I assume that what happens is that whenever we have a request, so I had that table, for example, for scheduling appointments, I'm going to store that information in a separate separate Kafka topic, and then I would have some job which goes there, reads the value, and executes that request, and that job knows how to handle retries and the rest. Here, for example, I had the table for vet appointment requests, and then I would assume that actually the requests are processed, and I'm getting some feedback on the time, or the time of the appointment, and so on, in reference to that appointment. And I can use also large language model then to use that information to come back to the user and share the final response that there is a scheduled appointment for you on this and that date. And then, of course, you can all shape it however you need. So that's how you can build agentic systems, agentic workflows, using those building blocks and using event-driven architecture. Again, my name is Olena. Yes, you can actually ask me questions now, also find me later. And yeah, so we also have, so just raise your hand so that we don't create a mess, and you will get a microphone.
Thank you, Olena. So questions?
Hi. So I'm pretty much new to the Agentic AI. I belong from the event-driven architecture systems and building the applications. We just have a curious question. So in Agentic AI, it is the multiple agents are going to form a workflow, right? And they are dynamically going to use either the embodied memory or the RAG, right, to come up with the final answer, right? So quick question is, while any agent is using RAG, for example, to figure out the output, can it be converted to embodied memory so that in the next iteration or in the future, it already knows it from the embodied memory and doesn't have to go via RAG route where it has to query, say, MongoDB or SQL or any other resource-consuming or time-consuming entity? Mm-hmm. Is that possible?
This is a great question. The challenge with this, and I would say the answer is sadly not really. I mean, you can do that. You can then fine-tune the model so you realize this is a common topic customers are asking about, and you actually go and fine-tune your model. However, normally you would not do it because fine-tuning takes time. And if there's also like question is popular right now but not popular later, I'm not sure you want to invest time into fine-tuning. Most probably you will continue retrieving, and retrieving that additional data is way cheaper if it's possible to retrieve. Some data is difficult just to retrieve. You want to actually train on a bigger data set like your model. But for those cases, if it's possible to do with additional context, just giving that additional text to models, and right now model context window is pretty big, so we don't have that huge limitation as we had in the past where you have to actually condense that information. So I believe that actually not really, that doesn't really, I don't see this happening what you are saying, yeah.
Hey Olena, this is Zamir. I'd like to know, all these features are available at this point in Confluent Flink or not?
Yes, they are. So we have ML Predict, we have, you can create a model, can create connection to Pinecone, to OpenAI, to Elasticsearch. So it's all there. At least I believe. It will be very, very soon. So I kind of, we even published a couple of blog posts on that, so you can find all that information.
Hey Olena, so this is Arun. Have a quick doubt, like I have worked on like models like Bedrock and all those things. So the agent that we are using, it is terms of cost perspective, it is included anything. And our one more doubt, like so it is when you get some retrieval from the whatever the queries that we ask, it can be integrated into any sort of open chatbot or something like that.
Could you repeat again? I'm sorry.
So the model which we are using in query, right? So it is in terms of cost perspective. It is something, it's a separate one or?
So here I was using OpenAI model.
Okay.
So or you can also use other models, other providers like Bedrock. You can access like Anthropic, and I believe this is right now the limitation. So not limitation, but this is like the pool of models you can use. I'm not sure, like with at least how we build it. I'm not sure if you can run. You can run actually your models in Amazon and then provide it as well. So you have flexibility to use any model which you can run externally. Yeah.
Yeah, it's kind of free to use. That's what you are. The models that you are using, right? So the open search models. So it's a paid one or like we need to pay for it?
So OpenAI models you need to pay for. So I mean the OpenAI model, and actually if you run even something with Amazon, for example, you run something separately, like you will still have to pay for execution. So sadly that's the case. Yeah.
Okay, got it. Thanks.
Hi, I didn't really understand the use of Flink. Can you just explain it once more? Where does it fit in this entire thing?
Yeah. So Flink is we need some kind of computational agent to transform the data, right? So we have the data flowing through the topics. For example, like we got information from the customer, we have that real-time data, but then we need to look at the data, and based on that data, we need to make requests. So we need to use kind of this computational engine to make a decision and make the request. So for example, the call to the large language model, or call to embedding model, or the transformation which I was showing with Java, user-defined functions. This is all building blocks of Apache Flink, and I'm sorry if I didn't mention that. So Kafka offers us amazing way to have this kind of this data streaming, like the rivers of data, but we need those points somewhere in the river is like transform or direct it to different directions, and this is where Flink is used.
Sorry, we are out of time. You can probably catch hold of Alina.
Yeah, thank you.
After the
You
session.
can come
Thank
to
you,
me
Alina.
and I
Thanks
will.
a lot for the questions.
Thank you so much for being here.